Alright, hello, good morning everybody. Good morning section B and also section D. Okay, thank you for joining this morning session. This is actually equivalent to makeup class kasi ang daming lecture sessions na behind tayo. So, I asked your laboratory instructor to let me borrow your time. And I think you are advanced on your laboratory classes. So, Ma'am Jerica decided to let me borrow your class schedule this morning. And this is actually our last lecture session for midterms. That's why I grabbed the opportunity to have a synchronous classes to these sections. Okay, so to give an idea to the students present today, all about organic reactions. Particularly, we will be learning the different reactions of hydrocarbons. Okay, so a good example of hydrocarbons, that is the simplest hydrocarbon. Then followed by alkenes. We will also discuss aromatic hydrocarbons. So, would be then okay. So in short, more on reactivity of hydrocarbons. Okay, alkanes, alkenes, alkynes, and benzene. So before we start the specific types of reactions ng these hydrocarbons, let me have a short introduction first. Let me record the session. Ayan. Okay, class, when we talk about organic reactions, the most common type or the most common mechanisms of reactions that organic molecules undergo is what we call polar reaction. So as written, by definition, polar reaction, this is an attraction, electrical attraction between a positive pole and a negative pole centers on functional groups in a certain molecule. Now, for you to easily understand the concept of polar reaction, it would be beneficial if we recall the term polar covalent bond. I believe you are familiar already with the term polar. Diba kapag sinabing ang isang bond, talking about a bond, kapag ang isang bond is considered polar covalent bond, meaning to say that bond, okay, actually resulted due to an observable dipole moment. So may presence of dipole moment, kumbaga, two atoms are being bonded due to high differences in their electronegativity. That is actually a result due to bonding of a particular atom, okay, to a highly electronegative atom. Hint natin to identify if that particular bond is polar, an atom is bonded to a highly electronegative atom. Okay? So with that, we could say na mayroong differences or unequal kumbaga yung sharing ng electrons. Okay? So this would cause unequal sharing of electrons. I repeat ha, kapag ang isang atom is bonded directly to a highly electronegative atom, okay, that will cause unequal sharing of electrons. Kasi yung mangyayari, magkakaroon ng dipole moment direction. Kumbaga, ang observable dipole moment would be, yung arrow would be pointing to that atom kung saan mas stronger yung pool of electrons. Siyempre, yung atom with a stronger pool of electrons is yung highly electronegative one. Kaya, this part here would become partially negative kung saan yung pool ng electrons tsaka yung tail naman dyan would initially become partially positive pole. Okay? So, polar, may dalawang pole being observed, a negative pole at saka a positive pole. Now, for most of the functional groups, particularly sa mga hydrocarbon derivatives na functional group, we could observe polarities or polarity pattern sa mga functional group. Let's say, for example, itong mga being presented. Diba, we all know that oxygen is a highly electronegative atom. Diba, ang oxygen isang halimbawa ng highly electronegative atom. So whenever a certain atom is directly bonded to oxygen, we consider that bond to be polar. So kanang mga highlighted color black na bond, that is said to be polar. So we could observe polarity pattern or polar bonds within the functional group, within certain functional group ng organic molecules. Yun na nga, particularly or specifically kapag ang carbon is bonded directly to oxygen, knowing that oxygen is highly electronegative. Okay? Now, with this characteristics ng mga functional group, meron tayong observable na polarity pattern sa kanila. So, during chemical reaction, we would conclude then na posible talaga yung polar reaction. Kasi kung babalikan natin yung definition ng polar reaction, there is an attraction between a positive pole and then a negative pole of functional groups in molecules. Okay, but of course, there are exceptions kasi hindi naman lahat ng functional groups palaging may oxygen present. A good example would be the simplest na mga functional groups. Ano ba yung mga simplest functional groups? Yun nga, yung mga hydrocarbons, yung mga purely hydrocarbons. Kasi what is being presented here, mga hydrocarbon derivatives lang ito sila. Yung mga derivatives, meron ng presence ng other highly electronegative atom. Okay? Pero kapag pure hydrocarbons, hydrogen at carbon lang yung makikita. So, a good example would be alkanes, diba? Alkanes, alkenes, alkynes. So, yun yung mga halimbawa for a while, ha? Okay. So, an exception, no? Exception of functional group na walang polar, no? Polar characteristic, yun na nga, alkenes. Alkenes, another example, alkenes. No? Alkenes, ayan. And also, alkynes, no? Ito yung mga halimbawa ng functional group na walang polarity. Obviously, walang observable polar bond. Kasi 'di ba kapag identical, recall, 'di ba kapag identical atoms are being bonded, for example, carbon bonded to another carbon, so we would conclude na equal lang yung sharing ng electrons. So kapag equal ang sharing ng electrons, it's the opposite type of bond, the non-polar, 'di ba? Non-polar covalent bond is being observed. Okay, so unlike sa mga hydrocarbon derivatives, like this is alcohol, diba? Alcohol, this is ester. O you tell me, what is this functional group? Ayan. A carbonyl with a terminal hydrogen. Sige nga. Please do not forget the functional groups kasi you will be bringing all that learnings until sa much more complex na topics natin. So what is that functional group? What about this one? Okay, if that is aldehyde, what about yung nasa baba? So these are all examples of derivatives. Okay, derivatives already of hydrocarbon. This is ketone. Excuse me. What about this one? A carbonyl with a terminal OH. COOH. This is carboxylic acid. Okay, and lastly, last example, COOR. Okay, this is ester. Okay, very good. So yun ha. But for most of the functional groups, may polarity pattern being observed. Kasi most of the common example, diba, ng mga organic molecules contains these derivatives of hydrocarbon. Maybe alcohol, ester, ether. This is ether. Okay, this is ether. Sorry. I mentioned ether, pero what I wrote is ester. That's ether, ROR, diba? COC. Sige. So yun ha, kapag polar reactions, balikan lang natin, it is an electrical interaction or attraction between a negative pole of a functional group and then a positive pole ng isang functional group. Okay? So polar reaction yan. Now, yung tanong ngayon, ano yung contribution ng polarity pattern being observed sa mga functional group to their chemical reactivity? Okay, actually yung concept na sabi naman kanina, diba, it is, yun na nga, kailangan yun para ang polar reaction mag-proceed. Kailangan may positive pole ang isa, yung isa naman naka-interact niya should have a negative pole. So ang mangyayari during chemical reaction kapag polar reaction, what happens here is yung electron rich, halimbawa this is the electron rich atom or the functional group na merong negative pole, no? Kasi electron rich, diba? Electron is highly negative in nature. Negative yung charge ng electron. So, yung electron-rich atom, yung mangyayari during chemical reaction, it will simply donate. No? It will donate pair of electrons to the electron poor. Okay? So, kung kapag electron poor, yung atom na yan, mababa yung negative, no? Negative charge niya. So, yung magdo-dominate sa kanya is the positive pole. Okay? So, yan yung concept ng polar reaction. An electron-rich, sulat ko lang ha, electron-rich atom, okay, will simply donate. Okay, magdo-donate siya ng pair of electrons to that electron poor. Okay, electron poor atom. Alright? So, yung electron poor atom is the one with a positive pole. No, positive pole. So, with that, we can now form a product. Kasi we're talking about reactions, di ba? Kapag reaction, there is always a product. No, there is always a product or mayroong new bond, no? May bagong bond being formed. Okay, so tandaan lang ha, kapag polar reaction, yung fundamental characteristic dyan, you have an electron-rich atom that will donate pair of electrons to the electron poor. Or the other way around, yung electron poor, it will be the one to accept. So, i-accept niya yung ibibigay na electron ng isang electron-rich atom. Alright? Now, in referring to electron-rich, electron-poor atom, meron tayong certain terms, no? Certain terms to easily classify an electron-rich versus an electron-poor atom. So meron tayong terminologies na usually ginagamit instead of identifying that particular group of atom as electron-rich, electron-poor. So meron tayong term. So tandaan nyo to, kapag polar reaction, we have nucleophile, meron din tayong tinatawag na electrophile. Okay, class, kapag ang isang atom, is electron-rich, okay, nasulat nyo muna, electron-rich. Diba? We have mentioned earlier na kapag electron-rich, it is the one considered nga negative polarized atom. Diba? Negative polarized. Yung negative pole, okay, negative or negatively polarized. Polarized atom. It makes sense kasi ang electron, sabi nga natin, ang electron is negative in nature. Okay, so kung electron-rich yung atom na yan, so yan yung negative polarized atom, a negative pole. Okay, so in order to form a bond, yung gagawin nga ng electron-rich in a certain polar reaction, siya yung magdodonate. Kasi siya yung electron-rich, siya yung magdodonate ng electron. So sulat nyo, it can form a bond, by donating, donating pair of electrons. Saan niya idodonate? O kapag polar reaction, electron-rich plus electron-poor. So idodonate niya yung pair of electrons sa electron-poor atom. Nakuha? So yan yung contribution kumbaga ng isang nucleophile. Okay, for it to form a bond, siya yung magdodonate ng pair of electrons to an electron-poor atom. Now, ma'am, bakit tinawag siyang nucleophile? Okay. As being written here, di ba, magre-react siya with an electron-poor, magbibigay siya ng pair of electrons sa isang electron-poor atom. And ang isang electron-poor atom, di ba, this is said to be, ang magdodominate sa kanya na charge would be positive. Sa isang electron-poor, sa isang electron-poor atom, ang magdodominate sa kanya na charge would be positively charged, no? Positively charged atom. And when we talk about parts of an atom, di ba sa centermost part ng atom, we could locate there the nucleus. If this is an atom, yung distant part ng nucleus negatively charged. Nandoon yung mga electrons. Now, inside the nucleus, we could locate here protons. Diba? Protons. Meaning to say, the reason why ang nucleus is positively charged, it's because of the proton. Okay? So, kung i-relate natin yung kumbaga yung charge ng nucleus, okay, we could conclude na ang nucleus is said to be positive, no? Positively charged. Now, bakit siya tinawag na nucleophile kapag electron-rich ang isang atom? Kasi nga, di ba, it would react to a positive charge, it would react to an electron-poor atom. Kumbaga, it is said to be nucleus-loving. Okay, nucleus-loving ang isang atom na electron-rich kasi yung hanap niya, positive. Nakuha? Kasi electron-rich na siya. Electron-rich na siya in nature. So for the polar reaction to proceed, hanap niya is isang electron-poor atom. And an electron-poor atom, positively charged yan. Diba? Kasi polar reaction dapat negative, i-react mo yan sa positive. Okay? So, nucleophile yung term kasi we consider electron-rich atom as nucleus-loving sila. And nucleus, di ba, is positively charged in nature. Nasulat ko again, ha? Ayan. Nucleus loving. Okay? So, kumbaga, do not be confused with the term nucleophile na characteristic niyan ng mismong atom. Okay? Ang inyuhang, kumbaga, palatandaan dyan is yung mismong term is based on the atom na ka-interact niya. Okay? Kasi electron-rich na siya in nature, yung hanap niya or yung ka-interact niya should be a positive one. It should be an electron-poor one. So, a nucleus, yun na nga, positively charged in nature, yung nucleus-loving, ang isang nucleophile. Okay? So, opposite naman yung electrophile. So, you simply kumbaga, ka-antonyms lang ng nucleophile ang electrophile. So, meaning to say, kapag electrophile, we are talking about an electron poor. So, sulat nyo, electron poor atom. No, electron poor. So, kapag electron poor, yung magdo-dominate would be a positive pole. So, ito yung positively, i-antonyms nyo lang yung nasa left side, ka-antonyms niya. Okay? So, polarized atom. And then, how does it form a bond? It can form a bond by accepting. Okay? So, siya yung mag-a-accept ng pair of electrons. So, it can form a bond by accepting. Okay? A pair of electrons. So, saan manggagaling yung pair of electrons na i-accept niya from an electron-rich. Okay, electron-rich atom. O, yung electron-rich atom na yan si nucleophile. Okay? So, kapag naman, so opposite ng nucleus-loving, electron-loving naman yung electrophile. Okay? Sulat nyo. Ako ang iro. Sorry. Okay. Sulat nyo, electron loving. Okay? Ayan. Sige. So, i-antonyms nyo lang. If you already are familiar with nucleophile, kahit i-memorize mo lang yung isa, memorize mo yung nucleophile, so pagdating sa electrophile, i-antonyms mo lang. Okay? Ayan. So, yan yung mga components ng isang polar reactants. No? Sa reactant side ng isang polar reaction, a nucleophile will react to an electrophile. So, ganun lang po. Kasi a nucleophile is the electron-rich atom. Electrophile is the electron-poor atom. Okay? Sige. We could also relate the definition ng nucleophile and electrophile to a base or an acid. When it comes to their ability to donate proton, pwede din natin ma-identify sino dyan sa dalawa yung mag-a-act as an acid, sino yung mag-a-act as a base, di ba? Yung concept natin about acid, most of the acid contains a proton. Any acid nga formula, they will always start with hydrogen. So we could tell then na ang isang acid is said to be proton donor. No, proton donor. Ngayon, between a nucleophile and electrophile, let me ask you, sino ulit sa nucleophile electrophile yung kumbaga much more positive? Kasi yung proton, it is highly positive. So between nucleophile and electrophile, sino yung naturally kumbaga proton rich or positive in nature? Mas marami yung positive. Is it nucleo or electrophile? Parang mahina kayo ako ang kung internet. Ayan. Galag ang ako ang chat box. Okay, very good. So electrophile, actually nakasulat na, di ba? So electrophile, they are the ones na positively in nature. Positive atom, electron poor, no? Electron poor. Meaning to say, it is the electrophile na rich in positive charge. So, kumbaga sila yung rich in proton. Kasi proton is positive, no? Positive in nature. So, between nucleophile and electrophile, ang comparable to the characteristic ng isang acid would be the electrophile. So, pwede nating isulat dito, okay, additional information lang, it could also act as acid. Kasi yun na nga, it could donate, no? It donates proton. Okay, kasi nga positive siya in nature. Ayan. Okay, it is able to donate proton. Kasi kapag acid, proton donor. Diba? Yan yung tandaan nyo, kapag acid, proton donor. Okay? Now, kapag naman nucleophile, electron-rich, diba? Ito, electron-rich. So, this would be the one to, ito yung mayroong ability to donate pair of electrons. And kapag ganyan yung characteristic niya, we could compare its characteristic to a base. So, acts as a base. Okay, or yung antonyms ng acid, able to donate proton. So, ito naman yung mag-a-accept, no? It accepts proton. Okay? So, ayan. Sige. So, yan yung differences ha, ng nucleophile tsaka electrophile. Sige. Now, yung tanong ngayon, pwede ba yung isang wala ng space, dito na lang. Pwede ba yung isang molecule could act both, no? Could act both. Pwede ba siyang both electrophile at the same time nucleophile? Okay? Actually, that is possible. That is possible kasi meron nga, 'di ba? Meron ngang compound nga amphoteric. Diba, kapag sinabing amphoteric, it could, no? It could either act as an acid, it could either act as a base. So, the same thing with a molecule na pwede din, merong mga molecule na pwedeng mag-act either as a nucleophile or an electrophile. Depende sa circumstances. So, example, let's have water, H2O. Diba? When we write the Lewis structure of water, yung oxygen will always carry two pairs, no, of lone pair, no, lone pair electrons, two pairs of lone electrons. Ayan. Now, with regards to water, this could act, no, as electrophile. Pwede itong mag-act as electrophile when siya mag-act as electrophile. Okay, mag-a-act siya ng electrophile whenever this atom is able to donate proton. Diba sabi natin, ang electrophile, okay, able to donate proton. It could act as an acid, okay, in short. So kapag yung water would donate, no, proton, okay, then that would act as electrophile in that case. Okay? If it donates proton. Okay? Kailan naman siya mag-act as nucleophile? So, magiging nucleophile siya. It will act as nucleophile. So, ayan. Okay? Kapag naman it donates pair of electrons, ano sabi natin kapag nucleophile? Ayan. Diba? It is able to donate pair of electrons. So, nucleophile naman siya, ang water, if that is the case. If in the reaction, it donates pair of electron. Is it capable to donate pair of electrons? Yes. Kasi yung oxygen niya, yan, tingnan yung oxygen ng water, di ba? It has an observable non-bonding electrons or lone pairs. So yan, kapag yung lone pairs ng water is being donated in a certain reaction, then in that case, water acts as a nucleophile. Okay? So if it donates pair of electrons, okay, or non-bonding. Sulat nyo, non-bonding na electrons. Okay, so yan. So yan yung halimbawa. Another example, let's say, ayan. Let's say carbonyl. Mga carbonyl containing, ayan. Okay, carbonyl containing na mga functional groups. Ayan, di ba? That is a carbonyl. Pwedeng mag-act ito either as a nucleophile or electrophile. So, it depende din sa circumstances. As if, for example, it will act as an electrophile class if yung mismong molecule, yung carbonyl portion, yung reaction occurs at its polarized, positively polarized carbon, if that is the case. If ang reaction mangyayari dito sa positively polarized carbon atom, then that will act as an electrophile. So, sulat nyo ha. Okay. If it reacts, okay, at its positively polarized carbon atom. Okay, kasi we define electrophile, di ba? Electrophile, definition natin, positively polarized atom. Okay? Now, if you compare the not compare, if you will check, no, if you examine the polarity pattern between carbon bonded to oxygen, yung dipole moment, diba, would be, okay, observed in this pattern. Kung baga, ang carbon will be carrying a partially positive charge, yung oxygen dyan would carry a partially negative charge kasi yung oxygen highly electronegative. Okay, highly electronegative siya. So if ever, yun na nga, ang reaction happens or occurs at its positively polarized carbon atom, then that will act as electrophile if that is the case. Pero kapag naman yung reaction, okay, happens, okay, in the negatively polarized oxygen naman, okay, dito mangyayari sa oxygen yung reaction, kumbaga yan yung reactive site ng mismong carbonyl compound, then that will act as nucleophile. Okay? Sulat nyo if it reacts at its excuse me, negatively, ayan, at its negatively polarized oxygen atom, okay, then that will act as a nucleophile. Balikan niyo lang yung definition ng nucleophile. Diba? Nucleophile is the one that is negatively polarized atom. Okay? So, yun na nga. For this example, kapag carbonyl, ang reaction mangyayari sa oxygen part, okay, dito, then that will act as a nucleophile. Kasi yung reaction, it occur at the negatively polarized center of the said functional group. Okay? So, ayan. So, posible na sa isang molecule could either act as a nucleophile or electrophile. Depende yan kung ano yung contribution niya sa mismong specific reaction. Okay, so please do not forget the characteristic of a nucleophile and then an electrophile. Okay, sige. So, done with the introduction on polar reaction. So, at this juncture, let us now begin discussing the different types or the specific types of reactions ng hydrocarbon. So, let's start with alkanes. So, this is alkanes, no? Okay, reactions of alkanes. Now, for alkanes, since this is the simplest, diba? Simplest family of organic molecules, we consider alkenes na less reactive. Okay? If we based it to its structural feature, kasi diba yung alkanes, yung makikita natin sa alkanes is a single bond between carbon, not carbon to hydrogen. Diba yan yung structural feature ng isang alkane. And we all know na itong structural feature is being observed also to any other functional group. That is why, as emphasized diba, sa ating discussion on functional group, in some other references, ang alkanes are not considered as functional group. Kasi nga, when we define functional group, recall natin, diba, kapag functional group, we define that as a part of the molecule where most of the reactions ng organic molecule occur. Now, in the case of alkanes, since wala siyang distinct nung structural feature na makikita lang sa kanya talaga, no? Then we consider alkanes as less reactive, no? Less reactive siya. Okay, so wala siyang distinct or kumbaga unique na functional group na makikita lang sa kanya. Okay? Kasi nga, itong carbon to carbon single bond, carbon to hydrogen single bond, makikita din naman yan sa lahat ng mga functional groups. Okay, so less reactive siya. That's why when we discuss the reactions of alkanes, we will only discuss two of the most common reactions ng alkanes. Okay, so yun na nga, yung pinaka-common is the combustion reaction. Yung combustion, you are familiar on this reaction already. Diba, yung combustion, meron siyang dalawang klase, the complete combustion and then the incomplete combustion. So, sa reactants na side, reactants, ito yung before the arrow, pointing to the product side. Okay, so before the arrow, andyan yung mga reactants, di ba? So, since we're talking about alkanes, so parte siya ng reactants. So, halimbawa, you have any alkanes. Ano ba yung general formula ng alkanes? Diba pag alkanes, CN, H2N plus 2. So, any alkanes, kapag sinabing combustion yung reaction, ang alkanes or hydrocarbons is being reacted with what? What diatomic molecule yung kailangan sa reactant side for the combustion reaction to proceed? Ano ba yung i-react natin sa alkanes kapag combustion? Ano yung gas na dapat present? Okay, very good. Kailangan ng oxygen, di ba? So, oxygen, it is stable. Okay? Stable siya sa nature at its diatomic na nature. Okay? So when we react or when we talk about combustion, you have an alkanes being reacted with oxygen. Now, how do we identify nga ang isang combustion is a complete combustion? If the oxygen being reacted to the alkane is sufficient, no, sufficient yung amount, no, sufficient amount of oxygen is being reacted enough, okay, yung amount ng oxygen being reacted to alkane, then that is considered complete. No, kapag complete ang combustion, all of the carbon atoms, all of this carbon atoms ng alkane are being combusted, being burned, no? Kaya ang observable sa product side, you will produce carbon dioxide and water. Excuse me. So yan yung kumbaga product ng complete excuse me ha for a while sa ayan. So yung product ng isang complete type of combustion, you have carbon dioxide and water. So as observed, wala nang natirang carbon. Walang natirang carbon na unburned. No, unburnt. So lahat ignited na, combusted. Kaya yung product, you have a gas, a carbon dioxide gas, and then water. No, water. Ayan. So completed yung combustion. Kapag naman incomplete type of combustion, what happens here is insufficient naman. Insufficient. Ayan, insufficient yung amount of oxygen being reacted to alkane. Okay, so let's say you have any alkanes here. So any alkane, CnH2n plus 2, being reacted with insufficient amount of oxygen. Okay, then in that case, ang observable na products, meron tayong makikitang presence of soot, no, merong mga black particles pa being observed sa product side. So yan yung kumbaga visible result to identify nga incomplete ang combustion na nangyari in that particular alkenes. So aside from carbon dioxide, water, merong a presence of carbon, soot yung itim-itim. Okay? And then another fatal gas is being produced, the carbon monoxide. Okay? Sige. So yung carbon soot, yan yung visible result ha. Visible result na incomplete yung combustion ng isang alkene. Kasi ibig sabihin hindi lahat ng carbon in that particular material, okay, are being combusted. So meron pang natirang mga carbon na hindi na sunog, no? Hindi na combusted, hindi na burned. Ayan. So these are the two types of combustion, and ito yung pinaka-common na reaction that alkenes undergo. No, yan yung pinaka-common. And I believe you are familiar with this reaction already. Okay, sige, proceed tayo with the second and also the last type of reaction na i-discuss natin under alkanes. Okay, madali lang yung alkanes. Yun na nga kasi less reactive siya, no? Less reactive. So konti lang yung reactions na i-discuss natin. Okay, so for halogenation naman, for this reaction, it occurs, please take note first, it occurs via free radical substitution. Okay, so kumbaga yan yung mechanism ng uh, ng halogenation reaction among alkanes. So from the term halogenation, what is being substituted, kasi substitution yung mechanism, no? What is being substituted to one of the hydrogen ng ng alkane, one of the hydrogen sa isang alkane is a halogen. Okay, diba? That's why merong capital X sub 2. Kasi diba yung X in chemistry, we classify that as halogen. So, a common halogen that is being substituted during halogenation ng alkanes are the following. Yung chlorine, also bromine. But if we compare the reactivity of chlorine saka bromine gas, compare natin yung dalawa, much more reactive yung chlorine. Okay? Chlorine gas compared to bromine. Kaya mas marami when you try to observe organic molecules, particularly those organic molecules containing halogens, yung pinaka common na halogen that is part of the organic molecule is yung chloro. Diba? Yung chloro. Ayan. Although silang dalawa, pwede naman silang mag-participate sa halogenation reaction. But ano lang, for reactivity, if you try to compare the reactivity ng dalawa, magdo-dominate yung kay chlorine gas. Excuse me. Ayan. It has something to do actually with the electronegativity of the molecule. Ayan. Sige. Now, another thing that you have to remember about halogenation of alkanes, this reaction could only proceed in the presence of a UV light. Okay? UV light or a high or elevated temperature extreme. No, presence of extreme or elevated temperature. Okay? So, either of that, UV light or extreme temperature, kailangan yan for the halogenation of alkanes to proceed. Yung UV light kasi or extreme temperature, kailangan yan in order to break the bond between the halogens. Kasi this is a diatomic, diba? This is a diatomic molecule. Kumbaga, you have a halogen bonded to that particular halogen. So, diatomic siya. In order to break this bond, kailangan ng extreme heat, okay, or UV light, para mabuo yung free radical or reactive form of halogen. The reactive form of halogen is yung free radical. Free radical, ayan, free radical, nature. Kasi kapag may odd, kumbaga odd na electron, okay, or unpaired na electron ang isang atom, that makes it reactive. Kumbaga unstable siya. Siyempre, any atom would love to become stable, di ba? Gusto nilang maging stable. Okay? So, para maging stable sila, magiging reactive sila at that state. Okay, reactive sila at that state. Kailangan nilang combine, no? Or mag-undergo ng chemical reaction for them to become stable. So that is the initial step na mangyayari during halogenation. Yung UV light is needed para ma-break yung bond sa mismong halogen that will be substituted. So in this case, we now form the reactive halogen free radical. So ang mangyayari dito on the product side, kapag halogenation ng alkanes, ang product is actually an alkyl halide. Substitution lang po yung mangyayari. One of the hydrogen ng terminal carbon ng isang alkane, it will be substituted with a halogen. So ang mangyayari sa product side, ayan, itong part na to, it it will be substituted already with that halogen that is being added or substituted. Okay? So this time, this is not already alkane. Diba ito? Alkane ito. Kapag nag-undergo yan ng halogenation, the product will now be an alkyl halide. No? Isa nang yung alkyl halide or halide. Diba? Halogen, alkyl halogen, no? Alkyl halide. Ayan, haloalkane. Diba? Yan yung mga terms natin kapag you have an alkane, then may presence ng halogen. Haloalkane, alkyl halides, the same lang yan. And then ano naman yung mangyayari sa isa pang halogen? Kasi isa lang yung sinubstitute. No? Yung isang halogen dyan would be part of the byproduct already. Part of the byproduct. So ito yung isang halogen. Okay? And it will be combined with the displaced hydrogen. Kasi meron kang dinisplace na hydrogen, di ba? Sa terminal carbon ng alkane. So ito lang yun. Ito yung hydrogen na being displaced initially from alkane. So purely free radical substitution yung nangyayari. Okay, so yan yung general na reaction kapag halogenation of alkane. So let's have a specific example. Okay, let's have, for instance, the alkane is, let's have the simplest alkane. So we have, diba, methane. So this is methane. If we undergo methane to chlorination, so this is already a specific halogen. Chlorine is the one that is being substituted. Okay? So chlorination in the presence of UV light, for instance. So ito, specific na to na example. Ang methane daw, it has a methane. Ayan. It undergo chlorination. Okay? A halogenation process. So, ang mangyayari yung chlorine first. Ayan. Yung chlorine, diatomic chlorine, yung bond between that atoms that holds two chlorines together, it will break. Okay? It will break. And then, it will form free radicals, no? Free radicals ng halogen. Then substitution will happen. One of the hydrogen ng terminal carbon of alkane will be displaced para ma-substitute yung halogen, yung free radical halogen. Okay? So it will now form, ayan, chloromethane. Okay? So yan lang po yung halogenation. Ako ha? And then the byproduct, you can write also the byproduct. Madali lang naman i-identify yung byproduct. Yung isa pang chlorine, okay, will combine with a displaced hydrogen. Ito yung hydrogen being displaced. But again ha, the major product is the alkyl halide. Okay, so in this specific example, the alkyl halide is the chloromethane. Diba? When you name that, you have a chloro and then one carbon, meth. No? So meth yung prefix na gagamitin kapag one carbon atom. So chloromethane. Chloromethane, or this is commonly known as chloroform. Ito din yung chloroform. Alright? So, yan yung halogenation. So, kahit mahaba pa yan na klase ng isang alkane, yung substitution, free radical substitution kapag halogenation, mangyayari lang po yan sa terminal carbon ha. Yan yung tandaan nyo. Terminal carbon ng alkane. So, one of the hydrogen ng terminal carbon of alkane will be displaced. Okay? And then substituted with that halogen, okay, that is being reacted to that alkane. Okay? Sige. Do you have any question regarding our first part, no, sa discussion, yung first part sa discussion? Yun lang po, yung reactions ng alkanes. You have combustion and then we also have halogenation. Walang tanong. So that we could proceed on alkenes. Wala. Ako na lang yung magtatanong, did you understand reactions? Nasa alkanes pa lang tayo, ha? Did you understand the concept about reactions of alkanes? Dalawa lang naman yun, combustion tsaka halogenation. Sometimes your clue sa type of reaction is the name of the reaction itself. Kapag sinabing halogenation, so what is being reacted to that particular organic material is the halogen. Kapag sinabing hydrogenation, hydrogen is being added. So if you will ask me what you need to be familiar of kapag sa reactivity na yung topic, you have to be familiar with all of the parts ng reaction. Mula sa reactants, ano ba yung kailangan na i-add? Ano yung reagents na kailangan for the reaction to proceed? Ano yung product? Ano yung major product? You have to know the product. You have to know how to name the product. You have to know how to write the complete equation ng chemical reaction. Okay? So yan yung kailangan yung malaman under reactions. Okay? Sige. Walang sumagot sa tanong ko. Did you understand reactions? Kahit yung reactions lang ng alkanes. Ako bitong iro kay grabe ka. Gusto siya mag-join sa class. Hello? Are you still there? Can you still hear me? Na akong iro. Okay. Wala naging nag-answer sa akong iro kay labad kayo. Yes, walang okay ra ba mo? Okay pa ba ang tanan? Ako sang stop.
Okay naman, pero malibog pa gamay, ma'am.
Okay. Sige, kadali lang kay akong iro. No. Gusto mag-join ako ang iro gyud. Kadali lang. No. Ay, so for a while, ha? Sige. So, ato tong i-cut ang first na recording kay daghan kaayog insert. Okay, sige, let's continue. You let me know if naa may libugan ha sa ato ang topic para atong ma-address diretso ang inyong question. I am trying my best na slowly na ko siya gina-discuss. Okay, sige. Let's proceed to the reactions naman of alkenes. Okay. So for alkenes, let's go back first to the functional group ng alkenes. You have to know be familiar with the functional group ng mismong organic molecule. So kapag alkenes, the functional group is the double bond carbon to carbon. So I repeat, the functional group observed sa alkene molecules is the double bond carbon to carbon. Ayan. Galag ang ako ang slide for a while. Okay. Ayun. Okay. Ayan. Now, I repeat, you have to know first the functional group of a certain organic molecule. Kasi, remember, we define functional group as the part of the molecule, the part of the organic molecule where most of the reactions occur. So, since we are discussing all about reactions of hydrocarbons, particularly in this slide, reactions of alkenes, dapat yung i-input ninyo sa utak nyo is the reactions in this case will happen on this part, no? On this part of the alkene molecule. Okay, sa mismong carbon to carbon, double bond. Doon mangyayari yung reaction. Okay? Now, comparing to alkenes are much more reactive this time. They are more reactive, of course, compared to alkenes. Kasi this time, it already contains multiple bonds, no? Meron ng presence, okay, of a functional group, particularly presence of multiple bonds. Now, let me ask you, kapag ba may presence of multiple bonds, do you think this part is electron rich or electron poor? Kapag may multiple bonds, ano ba yung component ng isang bond? Diba ang isang bond that is composed of or equivalent, that is equivalent to 2 electrons. Ang isang bond that is equivalent to 2 electrons. Now, in the case of alkenes, since yung functional group niya is yung mismong carbon to carbon double bond, multiple bond yung present, we could say na yung part na yan is electron rich. Okay? Kasi equivalent na yan to 4 electrons. Tama? And yung 4 electrons, it is being represented lang in a bonding pair, no? Bonding pair, bonding lines. Ayan, sorry. So, please take note, class, na ang presence of multiple bond, okay, presence of multiple bond, that will tell us na yung mismong parte na yan ng molecule is electron rich. O kapag electron rich, is it a nucleophile or an electrophile? Do not tell me nga nalimtan ninyo wag upaganit na ito i-discuss. Okay. So, very good. So, nucleophile ang isang electron-rich atom. Kapag polar reaction, therefore, if alkenes undergo polar reaction, it will be reacted to an electrophile. Yan yung tandaan nyo. Kung si alkene during a chemical reaction, polar reaction will act as the nucleophile, yung ka-interact niya sa reactant side would be an electrophile. Okay? Kasi yan yung concept ng polar reaction. Nucleophile plus electrophile. So, generally speaking, yung reactions ng alkenes, they undergo electrophilic type of reaction. Okay? Electrophilic type of reaction. Kasi nucleophile na siya in the first place. So, yung hanap niya, electrophile. Okay? Isang electron poor atom. Kasi rich na siya ng electron. So, electrophilic type of reaction, particularly electrophilic addition reaction. Yan yung general or most common type of reaction that alkenes undergo. So, they are being added. Itong portion na to, yung reactive site ng alkene, yung carbon to carbon double bond, that will undergo addition of electrophile. or electrophilic addition reaction. Now, we have different types of electrophilic addition reactions. We will be discussing all of that. Ang inyuhang i-take note judiciary would be the reagent. What would be the reagent being added? What would be the electrophile being added? What is the product? Okay. So what are these electrophilic addition? Okay, that alkenes undergo. So number one, we have what we call catalytic hydrogenation. So yun na nga, sabi ko, diba, yung mismong pangalan ng reaction, it will tell you already what group of atom is being added. Okay, so hydrogenation. So the electrophile that is being added is hydrogen. Okay? So the reagent na kailangan mo would be hydrogen gas. Okay? And sabi dito, this is catalytic hydrogenation. So kailangan for the reaction to proceed, dapat mayroong catalyst. Okay? So in this case, most common catalyst na ginagamit for hydrogenation reaction are metal catalyst. Okay, so example of metal catalyst, we have the platinum, palladium, nickel. Okay, so yun yung reagent na kailangan, okay, for the catalytic hydrogenation of alkenes to proceed. And from this reagent, we could form a stronger electrophile to be added in the alkene or double bond carbon to carbon, and that is the H+. That is the hydrogen or the hydrogen ion. 2 moles of hydrogen ion will be added sa mismong reactive site ng alkene. So, general reaction, ito yung mangyayari kapag catalytic hydrogenation of alkene. So, you have any alkenes, diba? Ito yung alkene. I-always emphasize yun na to na ang carbon to carbon double bond. Kasi nga, for any functional group, mangyayari ang reaction sa mismong functional group. Okay? Sa mismong functional group. So, for alkene, carbon to carbon double bond yung functional group, diba, ng alkene. So, that is the reactive site ng alkene. So, catalytic hydrogenation added with hydrogen gas. So, yan. That's why you can see there sa reactant, this is the reactant, no? Merong hydrogen gas. Okay, and again, for this reaction to proceed, kailangan ng metal catalyst. Okay, metal catalyst. So, example, the metal catalyst is palladium. Okay, so what happens here, class, ito yung tandaan nyo, kapag addition reaction, halimbawa, for alkenes, dito ko na lang isulat. Any addition reaction ng alkenes, initially, ang mangyayari po, there will be breaking of the pi bond. Okay? For any multiple bonds, meron talaga yung pi bonds. Yung pangalawang bond dyan sa double bond, yung pangalawang bond dyan is the pi bond. Yung unang bond dyan is the sigma bond. Okay? Yung pi bond is weaker. Weaker siya compared to the sigma bond. Okay? So yung pi bond will break. Kasi if it will not break, walang addition na mangyayari. Addition could only proceed if pi bond will break. Okay? So kapag yung bond na to will break, that will make each carbon highly reactive. Okay? It will make each carbon highly reactive kasi nagiba na tong pi bond. So, tig-iisa sila ng unpaired electron. Kasi in a bond, in one bond, meron yang electron. So, na-break yung bond, tig-iisa sila ng unpaired electron. And that makes each carbon highly reactive. Kaya mangyayari na this time yung addition reaction. And what is being added kapag catalytic hydrogenation? 2 moles of H plus. Dalawang H plus kasi we are adding hydrogen gas, a diatomic hydrogen gas. So you have an H plus, okay, another H plus. So yan yung being added sa mismong reactive carbon after breaking the pi bond. Okay, kaya mangyayari, you will form alkane. From alkene, you will form alkane. So nakuha, i-break mo na yung pi bond. Okay, para addition will happen. No, addition of the said electrophile will be added. So ito na yun. Ito yung dalawang H plus, no? Or hydrogen ion. Okay? That is being formed, no? From the reagent's hydrogen gas. Okay? So this is alkane. Yan yung product, major product ng catalytic hydrogenation of alkene. Okay, any alkene na merong double bond, syempre alkene would always have double bond. Kahit ilan pa yung double bond in an alkene, those alkene portion, those carbon to carbon double bond, they will be reduced into alkene. Okay? So kahit ilan pa yan, mare-reduce yan sila into alkene. So yan yung tandaan nyo, major product ng catalytic hydrogenation ng alkene is alkane. So this is a specific example. So the simplest alkene, you have ethene or the ethylene. That is the common name. It is being added with hydrogen gas, okay, in the presence of a nickel metal catalyst. Okay, so catalytic hydrogenation ito. Catalytic hydrogenation. You are adding hydrogen in the presence of a catalyst. Okay? So no problem with the identification of the type of reaction. But you have to also identify the product here. Okay? So ang mangyayari ulit, initially, breaking of the pi bond. So yung pangalawang bond, that is already a pi bond. So breaking of the pi bond for each of this carbon to be reactive. So that's the time you can now add the electrophile. Okay? The electrophile H+. So tig-iisa sila ng hydrogen kasi itong each of this carbon are highly reactive and they need to be stabilized. Okay, so they will be added with hydrogen, added with hydrogen. Ayan. Okay, so ito na yun. From ethene or ethylene, its alkane form is ethane. Okay, ethane. Alright, so that is catalytic hydrogenation. Okay, so this is just an additional information to everybody with regards to the production method of margarine. I know you are all familiar with margarine. Yung method for margarine to be produced is hydrogenation process. Okay, kasi initially yung unsaturated nga oil, okay, from liquid, if that is being hydrogenized, it undergo hydrogenation, yung fixed oil na unsaturated, masolidify na siya after hydrogenation. That is why yung margarine is a solid fat. No, solid fat. Kasi it undergo hydrogenation, making it a saturated one. A saturated one. So hydrogenation of unsaturated fixed oil, that will form margarine. Margarine this time is already saturated. Okay, saturated. Ayan. Okay, so that is all about catalytic hydrogenation. Okay, these are, sige, sample problem tayo. Okay, if you are asked to write the complete equation of the given problem, so you have, this is 2-hexene. Diba? This is 2-hexene. Tama ba? 1, 2, 3, 4, 5, 6. So at carbon 2, andoon yung double bond. So you simply highlight this part. Okay, do not be confused kung saan mangyayari yung reaction. Automatic doon sa functional group. Okay? So doon lang mangyayari yung reaction na catalytic hydrogenation. So again, it is being added with hydrogen gas. Kung isusulat mo yan in equation form, ito yung mangyayari. You have 2-hexene plus hydrogen gas in the presence of nickel catalyst. So, ano yung unang mangyayari? Breaking of the pi bond. Yan yung una. Okay? The pi bond will break for each of this carbon to become highly reactive. Kaya from CH, diba? CH, naging CH2, reducing the double bond. Kasi you break the pi bond. Diba? Initially, we break the pi bond. So, single bond na yun. Okay, single bond na yan. And that's the time you add the hydrogen. Okay, you add the hydrogen kasi we're talking about here hydrogenation. Okay, so what is being added is hydrogen. Okay, sige next. This is a skeletal sample of an alkene. Skeletal formula of an alkene. So 1, 2, 3, 5, 6, 7. So this is 3-heptene. No, that is 3-heptene. So 3-heptene undergo catalytic hydrogenation. So hydrogen gas is being added in the presence of platinum. Yung mga catalyst dyan, that is just to speed up the reaction. Diba? When we define catalyst, these are materials needed in the reaction to speed up, no, para faster yung reaction na mangyayari. Okay? But what participates in the electrophilic addition is yung mismong electrophile, the hydrogen gas. Yan yung yung mismong maa-add sa reactive site ng alkene. So, yun na nga, initially, yung mangyayari sa hydrogenation reaction, breaking of the pi bond, so you remove that double bond, yung second bond, kasi mabe-break yan, making these carbon, okay, highly reactive. Okay, so dyan maa-add yung hydrogen ion, AH. Kaya, you will form heptane. Heptane. 2, 4, 6. Okay, heptane. Nakuha? So that is all about catalytic hydrogenation. Okay, so just take note of the reagent. What is being added? Catalytic hydrogenation, so you're adding hydrogen gas in the presence of a catalyst. The product is always alkane. Okay, the product is always alkane. Okay? Sige. So I will just answer here para meron kayong sample problems na itatry during your independent study. So I will try ito, yung cyclic one, number 3. Okay, I repeat ha, I will emphasize nga lahat ng reactions, okay, ng organic molecules mangyayari sa functional group. So, kung titingnan mo yung molecule, it contains a double bond. So, this involved reaction of alkenes, So, you highlight directly immediately yung mismong functional group ng alkene, carbon to carbon, double bond, and makikita nyo it is added daw with hydrogen gas in the presence of a catalyst. So this is catalytic hydrogenation. Hydrogen gas, catalyst, catalytic hydrogenation yan. So you complete the equation. So added with hydrogen gas and then a nickel is the catalyst. Alkane yung dapat na product. So how to produce the alkane product? break una yung pi bond, no? I-break una yung pi bond to make each carbon highly reactive. Okay? So you add each of this carbon hydrogen. So ang mangyayari, you have a cycloalkane, okay? And then this part here from CH magiging CH2. And then you have CH3. So yan na yung product. Now you try to name this cycloalkane. What is the name of the cycloalkane? Sige nga. Do not forget also the naming. Because there will always be questions na you will not just write the complete equation, but you also need to name the product, no? So ano yung pangalan ng cycloalkane na to? Or hinay ang ako ang internet. Sige, what is the name of the cycloalkane? Anyone? Sige. Okay, 1-ethyl. Walang dash ha between word to word. So 1-ethyl, then continue. Cyclohexane. And since isa lang naman yung substituent, you can just write ethyl cyclohexane. Okay, ethyl cyclohexane. Okay, for the rest of the examples, you can try this at your home, no? For independent study. Okay, so yung clue lang, for number 1, dito mangyayari yung hydrogenation. Dito yung mangyayari yung hydrogenation for this part. Ayan. Okay? Now, if ever, let's try this naman. If ever, halimbawa lang, sa number 4, hindi lang isa yung double bond. Okay. Ayan. Let's try to have, ayan, more double bonds observed sa mismong molecule. So, halimbawa, meron ding double bond, okay, on the terminal carbon. So, dalawa yung double bond. Now, in that case, posible, no? Posible pa rin yung hydrogenation producing an alkane, provided that the concentration of the hydrogen being added should be higher. So, kumbaga, halimbawa, merong 2 moles of hydrogen being added. So, let me complete the equation, ha? So, halimbawa, ako siyang i-complete lang. So, plus 2 moles of hydrogen gas. Okay, 2 moles of hydrogen gas in the presence of a platinum catalyst. Ayan. So, posible, no, na reaction will still proceed. Okay? Madali lang kapag naka-skeletal formula. Kasi you simply omit this second bond. Then you will now produce the alkane form. No, alkane major product. Okay, so 1, 2, 3, 4, 5, 6, 7. Ayan. So that is the product. You simply remove the pi bonds. Kasi diba initially ang mangyayari kapag electrophilic addition, breaking of the pi bond. You break the pi bond, then that's the time hydrogen will be added. Now, since skeletal formula, ang hydrogen, diba, is imaginary. For any skeletal formula ng molecule, hydrogen is always imaginary. Okay? So, yun lang yung mangyayari kapag catalytic hydrogenation. Next, let's have halogenation. Familiar na kayo sa halogenation. So, the same with alkanes, ang mga alkenes then, they also undergo halogenation type of reaction. So what is being added here is halogen. So yung reagent, halogen gas. You can have chlorine gas or bromine gas. Okay? So the electrophile that will be added would be the chlorine ion, bromine ion. So depende. If chlorination siya, chlorine ion will be the electrophile that will be added. Kapag bromination, it's the bromine ion that will be added. So general reaction tayo. Ayan. So with regards to halogenation of alkene, please take note that it could happen in two ways, no? Depende sa solvent that is being added. So, pwede yung halogenation is in the presence of an inert solvent. So, example of an inert solvent. Ayan, i-zoom ko ha. Ayan, you have a chloroform. Sulat ko lang. Chloroform. This one is the dichloromethane. These are just inert solvent. And then the carbon tetrachloride. Okay? These are just examples of inert solvent na pwedeng gamitin for halogenation. But again, what is being added na electrophile is only the chlorine or the bromine gas. Okay? So, yung mechanism of halogenation among alkenes is, again, breaking of the pi bond first, okay, for each of the carbon to be reactive, to make them reactive. Okay? So, kapag reactive na sila, addition will, it would facilitate addition process. Okay? So, ang mangyayari, this halogen, okay, you will, from this halogen gas, you will produce an electrophile. The electrophile would be, ayan, in a free radical din na nature. So you will have, kapag reactive na itong carbon, each of these carbon, kapag naging reactive na sila, addition of halogen will then be facilitated. That's why you could see here, a vicinal dihalide is produced. Vicinal meaning magkatabi. Magkatabi yung halogen, okay, upon addition. Kasi syempre, the addition will happen to these double bond carbons, di ba? To the initially double bond carbons. So yun lang. Yun po yung mangyayari kapag halogenation. Okay? If inert solvent are being utilized, no, sa reaction, sa halogenation reaction, if inert solvent like chloroform, dichloromethane, carbon tetrachloride yung present na solvent, okay, kapag halogenation reaction. Na kapag naman, for a while, okay, ato sa i-erase, ayan. Kapag naman yung halogenation reaction, yung solvent na ginamit is water. Ayan. Diba this time water na yung solvent. It's still halogenation. Halogenation reaction pa rin, but the solvent that is being added is water. So this time hindi na vicinal dihalide yung product. Hindi na vicinal dihalide yung product, kundi halohydrin. Halohydrin. So, kumbaga yung mangyayari, so, balik tayo, breaking of the pi bond ulit, each carbon will become highly reactive. Ang maa-add this time would be one free radical halogen, and then on the other carbon naman, OH will be added. And this OH will be originally coming from water. No, galing yan sa tubig, no? From the solvent kasama ng halogen. Okay? So magdedepende yung product ng halogenation sa solvent na ginamit. So balikan natin dito. Ay, sorry. Ayan. So kapag ang solvent or inert solvent like chloroform, dichloromethane, carbon tetrachloride, the product is a vicinal dihalide. Kumbaga, dalawang halide will be added. Dalawang halogen will be added to each reactive site of alkene. Kapag naman water yung solvent, okay, being or present upon halogenation, halohydrine naman yung product. OH is being added to one carbon, and then on the other carbon, doon naman yung halogen. Okay, halogen being added. Okay, so halohydrine. Okay? Now, in order for you to predict the product, okay, product sa halogenation kapag yung solvent na ginamit is water, you have to know the degree of saturation ng carbon. Okay? Carbon atom or yung initially double bond carbon kanina. Okay? So, ang mangyayari dito, you have to check the degree of saturation of this double bond carbons. Dapat, the one with lesser hydrogen substituents, di ba may mga naka-attach pa dito sa each of this double bond carbon. So, titingnan mo, between these two double bond carbons, sino yung lesser hydrogen substituents, doon mo i-add yung OH. Okay, that will be your predictor. Okay, and that there is actually a rule that we follow. Bakit doon sa lesser hydrogen substituent i-add yung OH? So later, I will introduce to you that particular rule. So for now, just know that concept na kapag halogenation, syempre halohydrine yung magiging product, major product. Of course, you will get confused. Saan natin i-add yung OH? Saang carbon dito na to i-add yung OH? Okay? Sa left side, carbon ba? Or sa right side, carbon yung OH? Then you follow a particular rule. Later, i-introduce ko yung rule. So yung concept lang is, i-attach mo yung OH sa mismong carbon na lesser ang hydrogen substituent. Okay? So you simply compare saan dyang double bond carbon ang lesser hydrogen attachment. Okay, doon yung OH papunta. Okay? Sige, specific example tayo. So we have ethene. Ethene undergoes chlorination kasi chlorine yung being added na halogen. Okay? So this time, in the presence of carbon tetrachloride. And as mentioned earlier sa general reaction, kapag inert solvent like carbon tetrachloride is being added, okay, together with a halogen, ang magiging product would be a vicinal dihalide. Kumbaga, upon breaking this pi bond, for each of the carbon, they will be added with that particular halogen. So the halogen man specifically is a chlorine. So you have chlorine each. So vicinal, magkatabi yung halogen added. And when you name that, diba, that is 1,2-dichloroethane. So no problem with the name, no? So that's it for halogenation in the presence of carbon tetrachloride. Okay? Paano naman kapag the halogenation is the halogenation process undergo in the presence of water solvent, no? The presence of the solvent na water. So yung tandaan 'di ba natin na product halohydrine yung product dapat. Halohydrine. So kumbaga after breaking the pi bond, for each of this double bond carbon, they will be added with, one is the halogen, the other one is the OH. So halohydrine na yan. Halohydrine. Okay, so in this case, since pareha lang yung degree of saturation ng each carbon, tigdalawahan sila ng hydrogen. So either lang saan mo ilagay, saan mo i-add yung chloro, saan mo i-add yung OH. Okay? Pero kapag ganito yung case, halimbawa let's say CH3 for a while. If the case is CH3 then C, okay, ayan, then CH2, this time. So you have an alkene portion, so ito yung alkene, dito mangyayari yung double bond. Dito mangyayari rather yung reaction for a while. Sige. Pasensya na kasi ang mga iro kay nanggiaway. Sige, anyways, balik tayo sa other example. So you have 1 propene. So halimbawa, you have a 1 propene. If this undergoes chlorination and then in the presence of water as a solvent, if i-compare mo yung degree of saturation ng dalawang double bond carbon, i-compare mo ba yung number of hydrogen directly attached to these double bond carbon? On the left side, isa lang yung hydrogen niya. On the right side na carbon, dalawa yung hydrogen. Diba? Attached to that carbon. So if that is the case, magkaiba na yung degree of saturation. That's the time you use that concept, yung kanina na sinabi ko, the OH will be added to the carbon kung saan lesser yung hydrogen. So doon mo i-add yung OH. And then on the other side, kung saan yung mas maraming hydrogen, doon naman yung halogen. Okay, so break the pi bond. So, kumbaga ang mangyayari sa product, you have a CH3 and then a CH. Dito yung OH. Single bond na lang kasi you break the pi bond. Any addition reaction, break mo muna yung pi bond for the addition to be facilitated. Walang addition na mangyayari kung hindi mo break yung pi bond. Okay? And then C, di na pasigo for a while. So balik tayo. CH3. Ayan. Then CH. Dito yung OH. And then you have CH2. Dito naman yung chloro. So for this carbon, dyan naman yung chloro. Kasi this is halogenation, chlorination. The halogen being added is chlorine gas. Okay? So yung maa-add na halogen electrophile is the chloro. Okay? Sige, later I will introduce to you what is that rule na kung saan ko binase yung attachment of the OH. Okay, there is actually a rule to that. Okay, so tandaan ha, halogenation ng alkene, dalawa yung posibleng product. Vicinal dihalide kapag ang halogenation is in the presence of inert solvent like chloroform, dichloromethane, carbon tetrachloride. Pero kapag naman ang halogenation is in the presence of a water, halohydrin naman. Halohydrin yung product. Alright? Sige. For a while ha, let me take my personal necessity for a while. Sige. Let's have a sample problem naman. Sample problem, ayun. Sige, let's have number 3. Itong may cyclic. Okay, cyclic na structure. So this is a cycloalkene. Ayan. Let's try to name it first. I-name natin yung cycloalkene. No? Yung cycloalkene. So if we name this would be carbon 1. Ayan. Ayan. Then carbon 2, 3, 4, 5, 6. So the name would be 3,5-dimethyl. 3,5-dimethyl. And then cyclohexene. Okay? Ayan. Tama ba? 3,5-dimethyl and then cyclohexene. We do not locate anymore or assign anymore to the location of the double bond kasi 'di ba kapag cycloalkene isa lang yung double bond, automatic the double bond is present in between carbon 1 and carbon 2. Okay, always talaga yan kapag isa lang yung double bond sa isang cycloalkene. Okay, so the 3,5-dimethyl cyclohexene, it undergo halogenation, particularly chlorination in the presence of water, no, as a solvent. So in this case, the product should be a halohydrin, no? Halohydrin, yun yung tandaan nyo kapag, okay, halogenation with water, halohydrin dapat yung product. Yung electrophile that will be added, isa OH, yung isa halogen. Okay? So, if you try to write the major product here, copy mo lahat, no? Copy mo yan. Carbon 5, may methyl. Carbon 3, may methyl. You break the pi bond, no? Break natin yung pi bond for each of this carbon to be reactive. So, dito maa-add ang OH and then sa isa naman yung chloro. Nakuha? Now, in this case, parehas lang naman sila ng degree of saturation. Diba? Parehas sila ng degree of saturation. So, either dyan mo i-add yung OH at saka yung chloro. Okay? OH saka yung chloro. Parehas lang sila ba ng number of hydrogen? Ito, merong imaginary, di ba, na dalawang hydrogen. Ito din, may imaginary na dalawang hydrogen to make each of the double bond carbon merong apat na bonds. Okay? So, ang mangyayari dito, kahit saan mo lang i-add dyan yung OH at saka yung chloro. Okay? That will be the final answer or final major product. Ayan. So, up to you. Pwedeng dito yung chloro and then dito yung OH. Or the other product, pwedeng ayan. The other product, dito naman yung OH, dito yung chloro. Okay? So, yan. Do not be confused kung saan yung addition ng mismong electrophile. You highlight immediately the double bond. Kasi doon sa functional group, mangyayari always yung reaction. Okay? What about this one? Bromination. So you simply break the pi bond. What do you think would be the product? Is it a halohydrin or a vicinal dihalide? Bromination in the presence of water. What do you think would be the product? The general product. Is it a vicinal dihalide or a halohydrin? Okay, what do you think? Okay, very good. Halohydrin. Okay, so break the product. So kapag halohydrin, alam mo na ano yung electrophile that will be added. OH yung isa, ang isa naman is the halogen. So the halogen here is bromo, kasi bromination. So break the pi bond. So ito yung carbon na highly reactive ngayon. And kung i-check mo, parehas din sila ng degree of saturation. So either dyan, pwedeng dito yung OH, dito yung chloro, or vice versa. Dito sa kabila yung OH, dito yung bromo rather, the bromo. Okay, so let me write the possible products. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. No, 2, 4, 6. Okay, 2, 4, 6, 7. And then on the third, 1, 2, 3. On this third and fourth carbon, ito yung reactive site. Okay, so pwedeng dito yung chloro, not chloro, bromo rather. Bromo kasi bromination. And then on the other carbon naman, na reactive carbon, dito yung OH. Or the other product naman, na asa third carbon yung OH, pang-apat na carbon yung bromo. Okay? So, sulat ko na lang yung or. 1, 2, 3, 4, 5, 6. Ayan, 7. So, on the third carbon, pwedeng dito yung OH, fourth carbon, dito yung bromo. No? 1, 2, 3, 4, 5, 6, 7. Naglapas na. Wait, na 8 na noon. Ayan. 1, 2, 3, 4, 5, 6, 7. Okay, so make sure yung product mo, dapat same yung number ng carbon atoms. Okay, you have to be careful. 1, 2, 3, 4, 5, 6. 6 lang pala. 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 5, 6. Tama, 7. No? So, 2, 4, 6, 7. 2, 4, 6, 7. Okay. Ayan. Okay? So, the rest of the example, you try this, no? During your independent study. Number 1, tsaka number 4. Kung titingnan nyo, ang inert solvent na ginamit, or carbon tetrachloride. So, you will expect na dapat yung product vicinal dihalide. Magkatabing halogen. Okay, so dito mangyayari yung halogenation or number 1, dito naman. Okay? Sige. So, dalawa na yung natakal natin na electrophilic addition for alkene. Catalytic hydrogenation tsaka halogenation. Okay? Sige, let's have hydrohalogenation naman. Okay. Okay, for the third specific type of electrophilic addition, we have hydrogenation. Ayan. So you have a hydrogen, plus a halogen. So ibig sabihin yung reagent na kailangan natin is a hydrogen halide. Nakuha? What electrophile is being added this time is a hydrogen plus a halogen. Kumbaga, isang hydrogen halide ang being added. And an example of hydrogen halide, we have hydrogen chloride, hydrogen bromide, ayan. Or hydrochloric acid, hydrobromic acid. No, yan yung mga halimbawa, common na halimbawa ng reagent added during halogenation. And then the electrophile that will be added is of course the hydrogen ion and then the halogen ion, the chlorine ion, the chloro, and then the bromo. Okay? So galing lang din yan sa mismong reagent being added. Okay, so general reaction muna tayo. Okay? So mechanism of hydrohalogenation, so you will be needing hydrogen halide. So this could be either hydrogen chloride or hydrogen bromide. Now, for the addition to be facilitated, again, for the nth time, breaking of the pi bond first, for each of this double bond carbon to be reactive. Okay? So, magiging reactive sila, and they tend to be added with electrophile for them to be stable again. Okay? So, ang being added nga is the halogen and then the hydrogen ion. Kaya meron kang product na, what is the product? Alkyl. This is an alkyl halide. Alkyl halide because you have an alkane with a halogen. This is a halogen. Diba? Halogen yan. Now ngayon, for you to predict the major product ng hydrohalogenation, we have a certain rule to follow or for you to easily predict the major product ng hydrohalogenation. Now, this rule is what we call Markovnikov's rule. This will help you be guided how to easily predict the product of hydrohalogenation kasi you will be confused. Where will you add the hydrogen, saan naman papunta yung halogen? Okay? Sige. So for this Markovnikov's rule, this will be the concept, no? So ito yung tandaan nyo kapag Markovnikov's rule. Diba, the electrophiles that will be added, you have the hydrogen and then you have the halogen. So yung tanong ngayon, where will you add hydrogen? Where will you add halogen? Upon hydrohalogenation. So yung hydrogen, doon siya mapupunta sa carbon with greater number of hydrogen substituents. Nakuha? I repeat, excuse me, yung hydrogen class, it will be added to the carbon with greater number of hydrogen. So, kumbaga, i-compare mo doon sa double bond carbon, sino yung mas maraming hydrogen substituent doon? Doon papunta, doon sasama yung hydrogen as the electrophile that will be added. And then, yung natira, yung halogen, doon naman siya sa carbon with a lesser number of hydrogen substituent. So, halimbawa, for this example, so obviously, dito mangyayari yung hydrohalogenation. Okay, so what hydrohalogen is being added here is the hydrogen chloride. So for hydrogen chloride, syempre, you will produce here the electrophile H plus and then the Cl. No? The H plus and the Cl plus. Okay? So, ang mangyayari, hydrogen ion, then the chloride ion, it will be added to the carbon kung saan sila dapat maa-add using the Markovnikov's rule. You simply compare the degree of saturation for each of this double bond carbon. So breaking of the pi bond first, and then, diba, each carbon will become highly reactive. Compare mo dyan, sino yung mas maraming hydrogen? Sino yung much greater number of hydrogen? Doon mo isasama ang hydrogen ion as the electrophile. Kaya you'll see here sa product side, from CH2 on this terminal carbon again, CH3, kasi yan yung carbon na mas marami, yung hydrogen. And then on the other carbon, ito on the left side, isa lang yung hydrogen meron sa kanya. That's why the chloro will be added on that carbon. So yun lang po yung Markovnikov's rule. Okay? So I repeat, kung nasaan yung more hydrogen substituents, doon sasama yung hydrogen. Okay? Sige. So let's have the following example. Let's have number 1. Ayan. So for example, hydrohalogenation of this cycloalkene. What is this cycloalkene? 3, 4, 5. This is 1,5-dimethyl, but this is 1,5-dimethyl cyclopentene. Ayan. Cyclopentene. So if this undergoes hydrohalogenation, okay, it will form a cycloalkane with a halogen as a substituent. So you simply copy the whole structure. Yan, CH3, copy first. And then proceed with the mechanism of reaction. You break the pi bond. Ayan. Break the pi bond. So wala na yung double bond. And then you compare which of these two carbons ang more hydrogen. More hydrogen. Doon mapupunta yung H+. And then yung bromo naman doon sa mas konti, no? Konti yung hydrogen. So you compare, this carbon meron siyang dalawang imaginary hydrogen. This one meron siyang isang hydrogen imaginary. Okay? So in that case, we would expect na on this carbon na lesser ang hydrogen. Ayan. On this carbon na lesser ang hydrogen, this is where the chloro will be, not chloro, bromo pala, kasi bromination. Bromo will be added kasi lesser yung hydrogen. And then the one with more hydrogen, nandiyan naman yung hydrogens. And since skeletal lang naman yung skeletal formula, or naka-skeletal structure, it's okay na hindi nyo na ilagay yung hydrogen kasi automatic, imaginary dyan yung hydrogen. Okay? So, ayan. Sige, let's have another example. Etong number 2. Number 2. Sige. So, etong hinighlight ko, dyan mangyayari yung hydrogen halogenation. So, hydrogen halogenation, what will be added? H+, and then the chloro. Okay? As the electrophile. So, you compare. By just looking at the double bond carbons, makikita nyo na agad sino yung mas marami yung hydrogen. Doon mapupunta si hydrogen class. So, you copy the whole structure CH3 parenthesis 2. Then itong carbon na to, okay, this will be the one added with the chloro kasi what is being added is hydrogen chloride. So yung halogen mapupunta sa carbon with lesser or wala nang hydrogen substituents. And then dito naman magiging CH3. Nakuha. You simply compare. Sino dyan yung mas marami ang hydrogen substituents? Okay, you highlight immediately the double bond carbons. Okay? Then, compare the degree of saturation. Okay, so for this part, you try this, no? During your independent study. Okay? Now, paano naman, class, if yung degree of saturation the same? So, if, no? Kasi meron tayong mga cases na pwedeng upon comparing the double bond carbons, the same yung degree of saturation, the same sila ng number of hydrogen present. So say for example, CH3, ayan, CH2, CH, and then CH3. Ayan. Okay. So for example, for 2-pentene, now this is 2-pentene. If this undergoes hydrohalogenation, excuse me, we could actually produce a mixture of addition products. Kasi, upon comparing the number of hydrogen for each double bond carbon, parehas lang sila ng degree of saturation. Parehas lang. Each has one. Okay? Each has one hydrogen atom. So, dili na to magamit ang Markovnikov's rule. No? Di na to siya magamit kay, di ba, it has something to do with the number of hydrogen substituents on that carbon atom. Pero when you try to check, parehas lang naman ng degree of saturation, so that's the time you will arrive, no, to a mixture of addition products. So kumbaga, pwedeng yung isang product dito mo i-add yung hydrogen, and then on the other, ayan, carbon naman, dito yung chloro. Then CH3. And then the other product, sa kabilang side naman yung chloro, and then sa kabilang side yung hydrogen ion that will be added. So CH3, CH2, then on this carbon, dito naman yung chloro. And then on the next carbon, dito yung hydrogen. Kaya magiging CH2, CH3. Nakuha? So, pwedeng mixture of addition products yung mapoproduce. Okay, so this is only possible if yung degree of saturation upon comparing parehas lang sila ng number of hydrogen, no? Hydrogen substituents. So mixture, you really have to provide the mixture of addition products. Okay? Now another na case, if ever, sulat nyo, if in case the hydrohalogenation process is, let's say, it happens in the presence of an alkyl peroxide. So say for example, you have CH3, let's say, ayan. And then CH, tama ba? Okay. Then CH2. No? So say for example, in this case, in this example, add tayo ng hydrogen bromide. Let me erase this part, para may space for me to write. Okay. So During hydrogen halogenation in the presence of hydrogen bromide, and then merong alkyl peroxide present. Alkyl peroxide present. So a good example of alkyl peroxide is yung simplest peroxide, no, yung hydrogen. Ayan, hydrogen peroxide. So if ever ito yung reagent na makikita mo sa equation class. If ever you will observe a hydrohalogenation, and then the reagent being added are hydrogen bromide in the presence of alkyl peroxide. Example, hydrogen peroxide. If that is the case, this is against the Markovnikov's rule. Kasi ang mangyayari, the alkyl peroxide, it would alter the regioselectivity ng mga electrophile being added. So kumbaga, instead of Markovnikov's rule, it will follow anti-Markovnikov's rule. Okay? This is only the case if hydrogen bromide in the presence of alkyl peroxide. Yun lang yung tatandaan nyo. Kapag ang reagent being added, hydrogen bromide in the presence of alkyl peroxide, anti-Markovnikov's rule. Yes, bromide only. Hydrogen bromide only. Okay? In the presence of alkyl peroxide, anti-Markovnikov's yung mangyayari. Opposite ng Markovnikov's rule. Diba sa Markovnikov's rule, ang hydrogen will be added to the carbon na marami yung hydrogen substituent. So, anti-Markovnikov's, this time, kung sino yung mas marami ang hydrogen substituents, doon mapupunta yung bromo. Okay? Kabaliktaran lang ng Markovnikov's rule, kaya anti. Okay, baliktarin nyo lang yung Markovnikov's rule. If ito yung reagent being involved sa reaction. So, yung magiging product, if we predict it, CH3, and then CH, then may substituent dito sa taas. Single bond na, itong CH2 dito, kabaliktaran naman ng Markovnikov's, hindi na dyan papunta yung hydrogen ion. Dito na yung bromo, and then this carbon na lesser yung hydrogen substituent, dyan mapupunta yung ayan, hydrogen. Kaya magiging CH2. Okay, you can write there immediately CH2. Nakuha. So yan yung sense of alkyl peroxide. Okay, anti-Markovnikov's rule. Okay, so tatlo na yung reaction na na-discuss natin for alkene. Ano yung una? Hydrogenation, catalytic hydrogenation, halogenation, and then the hydrohalogenation. Okay? And then it follows Markovnikov's rule generally, except kapag ito yung reagent. Okay, so these are, wala nang halimbawa. Proceed na tayo sa hydration. Wala na bang example? Tapos na pala tayo sa example kanina ng hydrogen, hydrohalogenation. Sige, proceed na tayo sa pang-apat. No, pang-apat na example ng electrophilic addition reaction. Okay, so we have hydration. From the word hydration, hydrate, diba? Hydrate. So this time, what is being added is water. Okay, so this is also known as addition of water. Okay, this is also known as addition of water. So yung reagent obviously would be water, and usually, commonly na nangyayari kapag hydration, this is the reaction proceeds in the presence of an acid catalyst. So usually, it is added with an acidic na solution. So example would be sulfuric acid. Ayan, yan yung pinaka-common na acid catalyst, no? To facilitate hydration reaction ng alkene. So what would be the electrophile that will be added during hydration reaction? So you will have the H plus and then the OH. The H plus and then the OH. Okay, so galing yan mismo sa water being added. OH and then H plus. So general reaction, you have hydration ng alkene. Water is being added again in the presence of an acid. Okay, in the presence of an acid. So ang mangyayari, mechanism ng reaction, break ulit the pi bond. Break the pi bond, so magiging reactive each of this carbon. So that's the time electrophile will now be added. So ano yung electrophile na that will be produced from water? The H plus and then the OH. Okay? So you will produce here generally an alcohol as a product. So general product kapag hydration, alcohol. So yung tanong, ma'am, saan namin i-add yung OH, saan naman yung hydrogen? Okay, so the same, it follows Markovnikov's rule. Markovnikov's rule. Okay? So, ulitin lang natin yung hydrogen. Kung following the Markovnikov's rule ha, hydrogen will be added to that carbon na greater yung number of hydrogen substituents. Okay, yan yung tandaan nyo kapag Markovnikov's. Nasaan mas maraming hydrogen substituents, doon papunta, doon sasama din si hydrogen. Okay? So that's hydration. Alright? Sige. So, specific example, ayan, sample problem. Let's have number 3 daw. Sige ba? Try natin yung number 3. Okay. So, obviously, mangyayari yung reaction on this part of the molecule. Kasi nandiyan yung double bond. Okay? So, hydration ito kasi you will, as you can check, the reagents being added, water in the presence of an acid, sulfuric acid. So, hydration itong type na reaction na to. So, mechanism of hydration reaction, break the pi bond. Ayan. So, sulat natin ha. So, you have a cyclohexane. So, na-break yung pi bond, one single bond na lang. And then, after breaking the pi bond, this carbon, let's highlight it with color blue. This carbon will now become reactive. Yung tanong, saan dyan mapupunta yung hydrogen, saan naman yung OH? So obviously, itong carbon na to has more hydrogen substituents. Meron siyang dalawa. Whereas dito walang hydrogen available. Okay, walang hydrogen available in this part. Okay? Kasi if you will count the number of bonds ng mismong carbon na to, ito, meron na siyang 4, di ba? Initially, kanina, 4. So, 1, 2, 3, 4. And remember, a carbon, maximum stable number niya ng bonds is 4. So, wala na dyang hydrogen. Okay? So, yung nasa taas na carbon, marami yung hydrogen substituents niya. So, doon mapupunta yung hydrogen. So, magiging CH3. And then, on this carbon, sa baba, dito naman yung OH. Kasi kapag hydration, ang electrophile, H plus at saka OH. Hydration. H plus OH yung electrophile that will be added. Then following Markovnikov's rule. Okay? Sige. So, the same concept will be applied for the following problems. Okay, try natin yung last, yung number 4. O, ayan. So, obvious naman na ang reaction, hydration reaction will happen on that part of alkene molecule. So, hydration, break the pi bond. Now, each of this carbon will become reactive. So, ang mangyayari, there will be addition of the electrophiles, OH, and the H+. So, obviously, if you compare the number of hydrogen substituents for this carbon, mas marami. Ito, merong 2 hydrogen directly attached to it. So, dyan maa-add yung isa pang hydrogen. Okay? Upon hydration reaction. Okay? So, ang mangyayari sa product, you will have, ayan, CH3, and then dito naman yung OH, and then CH3. Ayan. Okay? So, Markovnikov's rule. Okay, it follows Markovnikov's rule. So, stable. Stable lahat ng atom. Okay, so we are done with the electrophilic addition of alkenes. Okay, electrophilic addition ng alkenes. Okay, so ato lang i-wrap up, okay, for the different electrophilic reactions ng alkenes. Recall natin, we have catalytic hydrogenation. We also have ayan, halogenation. Depende yung product sa present na solvent, okay, added together with the halogen. So, pwedeng vicinal dihalide, halohydrin yung product. And then we also have hydrohalogenation. So, it follows Markovnikov's rule. And then finally, we have hydration. It also follows Markovnikov's rule. Okay? Sige, let us proceed to the second classification ng alkenes reaction. Okay? So yung kanina, mga electrophilic addition, reaction of alkenes. Now, alkenes can also undergo oxidation type of reaction. Generally speaking, kapag sinabing oxidation type of reaction, from the word oxidation, we are adding here oxygen atom. So, addition of oxygen atom, or this also means reduction, no? Reduction or removal, no? Removal of hydrogen atom. Okay, so that is the concept of oxidation. Addition of oxygen, or it is also equivalent to removal of hydrogen atom. So for any oxidation reaction, of course, kailangan ng oxidizing agent. Diba? For any oxidation reaction, kailangan ng oxidizing agent. Now, we have 2 specific examples of oxidation reaction that alkenes undergo. Meron tayong tinatawag na hydroxylation. Hydroxylation reaction. Okay. Or this is also known as glycol formation because it has something to do with the product that is being formed upon hydroxylation. So, for hydroxylation reaction, the reagent, no? Ang reagent na kailangan natin is, of course, kailangan ng oxidizing agent. Okay, oxidizing agent would be a potassium permanganate, And dapat the environment upon oxidation or hydroxylation, dapat basic yung environment. So kapag basic ang environment, merong presence of a base solution. So a good example of a base solution is sodium hydroxide. Okay? Plus, dapat neutral yung solution. Okay? Neutral yung solution or diluted yung solution. Okay? Susulat nyo din. Diluted ang solution plus the temperature, it must be cold. Okay? So yan yung mga criteria kapag glycol formation or hydroxylation with an oxidizing agent. And the electrophile that will be produced out of these reagents being added is 2 moles of OH. That's why a glycol is being produced. So, ito yung general reaction ng hydroxylation. Ito lang tandaan nyo, kailangan ng potassium permanganate. So kapag nakakita kayo sa general reaction, may potassium permanganate and then may nakasulat in the presence of basic solution, merong sodium hydroxide and it is in a cold solution. That is hydroxylation. And it will form a glycol. No, it will form a glycol. Glycol, ibig sabihin vicinal diol, yung addition ng electrophile, okay, magkatabi. Doon mismo sa double bond carbons, okay, which is actually the functional group of alkene. Doon mismo sa reactive site ng alkene, doon i-add yung 2 electrophile, which is in this case the OH. Okay? And this is just a visible result sa mismong reaction. In any glycol formation reaction, there is always an observable visible result, formation of a brown precipitate. That is the manganese dioxide. Okay? And generally speaking, itong whole reaction na to, this is also what we call the Bayer's test for unsaturation. You will encounter this next semester sa inyong biochemistry. You will observe this in your laboratory experiment. Kapag hydroxylation or glycol formation, you will always observe on the test tube a visible product which is a brown precipitate. That is the positive result of unsaturation ng isang compound. Kasi unsaturated, di ba, ang isang alkene? Okay, basing on its structure, it is unsaturated kasi merong presence ng multiple bond. Unsaturated. Structurally speaking, kapag may multiple bond, unsaturated yung isang, yung mismong compound or sample. Okay? So, yan lang yung tandaan nyo kapag hydroxylation, kailangan ng potassium permanganate as the oxidizing agent in a basic environment, in a cold solution, and the product is a vicinal diol. Okay? Or a glycol. And the visible result, brown precipitate manganese dioxide. Okay? Another thing, pwede din naman yung hydroxylation or glycol formation will proceed using a different oxidizing agent. You can have osmium tetroxide. Osmium tetroxide could also be used as the oxidizing agent. Okay? Osmium, sulat ko na lang. Yan. Or osmium tetroxide. Ayan. And again, the product is still glycol. Okay, ito yung product. Glycol or vicinal diol. Syempre, wala nang manganese dioxide kasi osmium tetroxide na yung ginamit. Okay? Vicinal diol is the major product. Okay? Or the glycol is the major product. Excuse me. Sige. You can take your snacks or your lunch. It's okay. Walay problema sa ako if unsa inyo hagi pang buhatera. I will just continue my discussion. Okay? It's not a problem with me if mag-take mo sa inyong personal necessities, you take your snacks, or whatsoever. Okay? Sige. And the last na oxidation reaction among alkenes is the oxidative cleavage. Okay? So yung oxidative cleavage naman is the direct opposite of hydroxylation. Kasi this time, the environment of the added na oxidizing agent is in an acidic solution. Diba kanina basic yung solution for hydroxylation? Plus, cold yung solution. This time, acidic yung solution, so it could be in the presence of sulfuric acid. Plus, merong application of heat, no? Heat is applied, no? Heat is applied here. So, hot yung solution. So, yan yung reagent na kailangan for the oxidative cleavage to proceed. So, yung general reaction, so you have an alkene, any alkene, upon the addition of potassium permanganate, no, in a hot solution, acidic solution, take note, it will produce varying products. No? The products may vary. Pwedeng yung product, carbon dioxide. The product, you can produce a carboxylic acid product, or you could actually produce an ester. No? So, in order for you to identify ano yung product during oxidative cleavage, you have to examine first what is the carbon double bond that you cleaved. No, what is the nature of the carbon double bond that you cleave? Literal to. Literal na sa mismong reactive site. Diba ito yung reactive site ng alkene. Kapag oxidative cleavage, there will be mahahati. No? Mahahati itong reactive site. So, kumbaga, meron kang dalawang major products na mabubuo upon cleavage. Okay? Now, in order for you to identify what would be the cleaved products, kung carbon dioxide ba, carboxylic acid ba, or ester, titingnan mo dapat yung cleaved, nature of the cleaved product. Okay? So, ito yung tatandaan nyo. Let's have this slide. So, if yung cleaved product is, ito example, from this double bond carbon, you cleave this one. If itong part na to, or this part, is a carbon with no organic molecule directly attached to it, puro hydrogen lang yung naka-attach. Itong cleave nga part ba? This will automatically become carbon dioxide. Ako ha? Yung mismong cleaved product is a carbon double bond with no organic molecule directly attached to it. Puro hydrogen lang yung naka-attach sa kanya, then that will become carbon dioxide. Now, if ever naman, itong cleaved part, so may it be itong nasa left side or itong nasa right side, itong cleaved part meron ng presence of one organic molecule and then yung isa hydrogen, this part will become carboxylic acid. Okay? That will become carboxylic acid. By the way, later na lang. Okay? Carboxylic. Nasulat ko yung, ayan. Okay? Carboxylic acid is an OH, no? Ayan. Okay. Okay, and then lastly, kapag naman ang cleaved, ayaw na sumulat, na-erase na gyud for a while ha, para dili siya ma-erase, let me have another slide, okay. Dito na lang. Nasulat ko ulit. Okay. So yung carbon, kapag ang double bond, carbon being cleaved, walang organic molecule directly attached to it. So ito, magiging carbon dioxide. If ang carbon, meron ng isang organic molecule, and then a hydrogen, isang hydrogen, ito yung magiging, ano sabi ko kanina, carboxylic acid. Magiging carboxylic acid yan. And then kapag naman ang cleaved double bond carbon, puro organic molecule na yung naka-attach. Okay? Puro organic molecule na yung naka-attach. It's not ester pala. Yung kanina kasi na nalagay sa PowerPoint slide, it's ester, but it should be ketone. No? Ketone dapat. A while, ha? Yeah, it should be ketone, not ester. Okay? You try to look at the organic group directly attached to a carbon. Puro R group na. And obviously, that will form a ketone. No? That will form a ketone. Tama, ketone. Sige. So, yan yung tandaan nyo ha kapag cleavage, no? Oxidative cleavage. Kailangan, you really have to cleave the reactive site ng alkene. And then you have to identify what is the nature of the cleaved portion. If itong carbon na to, puro hydrogen yung naka-attach sa kanya, automatic that part will become carbon dioxide. And then what about the other part? Then you check the other part. Kapag yung other cleaved carbon, double bond, contains one, if it contains one organic group directly attached to that double bond carbon, then that part, that portion will become carboxylic acid. Okay? Or kapag naman dalawa na yung organic group directly attached to that double bond carbon, that will become a ketone. Okay? Carboxylic acid, carbon dioxide. Let's have a specific example para mas ma-appreciate nyo or mas madali maintindihan. Let's have this. Okay. Ano to ha? Edit. This should be ketone. No? RCOR lang dapat. No? Okay. RCOR lang dapat siya. Try na to i-double check ha. Baka tama yung ester. Ketone lang talaga. Ketone lang siya. Hindi siya ester. Okay? So, paki-erase yung isang oxygen dyan sa notes nyo. It should be ketone lang. Okay? Sige, let's have a specific example. Let's have number 1. Halimbawa, itong number 1, you have 1 propene. No? So, that is 1 propene. Diri na lang ta sa... Okay. Ayan. Baka ma-erase ulit. Another na lang na slide. Okay. Sige. So, example lang to. Example. Hapit na ang time. So, 1 propene. So, CH3, CH lang, no? Tama ba? CH lang yung 1 propene. CH, and then CH2. 1, 2, 3. Okay. Okay. CH3CH, then CH2. CH3CH, and CH2. Okay. So, if it undergoes oxidative cleavage, so dapat what are being added, ang reagent should be a potassium permanganate in the presence of an acidic solution. So, let's say, for example, in the presence of sulfuric acid and then may applied heat. So, in that case, if you are to identify the reaction, sulat nyo, oxidative cleavage ito. And you have to take note na the product may vary kapag oxidative cleavage. So, how will you identify the major product, okay, upon oxidative cleavage. So from this reactive site, you simply cleaved, no? Cleave that portion. Cleave that double bonds, no? Cleave that double bonds. And then you compare. You examine, rather. You examine this part. Ibuwag ko ha. From this cleaved part, this carbon has direct attachment of two hydrogen, di ba? CH2 siya. Meaning meron siyang direct attachment na two hydrogen. Ano sabi ko sa inyo? Kapag ang cleaved portion walang organic group of atoms, what happens to that portion? Will it become a carbon dioxide, a carboxylic acid, or a ketone? Yeah, ano sabi ko kanina? Kapag dalawang hydrogen lang attached sa kanya, automatic that will become, so isang product obviously is a carbon dioxide. No? So that part will become a carbon dioxide. What about the other cleaved portion? You just have to cleave it. No? Yung other cleaved portion, itong part na to ba? Itong part na to, okay? Itong other cleaved part, you try to check. You have a carbon, then meron siyang isang hydrogen. Meron siyang isang hydrogen, and then meron siyang organic group, ACH3. So meron siyang isang R group, isang hydrogen. Ano sabi ko kanina? What happens to that part? Oh, very good. It will become carboxylic acid. That is how you identify the product of oxidative cleavage. You cleaved the portions and then you try to examine ano yung characteristic ng mga cleaved portion. So meron siyang isang R group. This is an R group, di ba? Merong carbon, another carbon directly attached to that cleaved double bond carbon. So magiging carboxylic acid. Paano yan magiging carboxylic acid? This cleaved carbon will be oxidized. So simply add oxygen. Okay? And then you copy this organic group. Okay? Copy that organic group. Ang hydrogen po, class, it is always highly oxidizable. And yung oxidizable form of hydrogen, it will form, wala na. It will always form hydroxyl. I repeat ha, ang hydrogen, it will always oxidize to its hydroxyl form. Kaya, you add there OH. Okay? OH. Kaya, if you try to check, this is already carboxylic acid. Kung imo na siyang try to write it, okay? In this way, CH3, and then, ayan, double bond and the OH. It's the same. Parehas ra ni sila. No? Parehas ra na sila. Okay? So, it's a carboxylic acid. No? It's a carboxylic acid. You just have to check lang yun, the cleaved portion. Okay? Sige, what else? Let's have the... Time na ba? O, napay time. What about the... itong number 3. Try natin yung number 3. Okay? So, this part will be cleaved. Okay? Obviously, this is all oxidative cleavage kasi you have a potassium permanganate, then acidic yung environment. So, oxidative cleavage yan. Okay? So, cleave that part. Ano yung mangyayari sa portion na to? A carbon, then may CH2. Ano yung mangyayari yung nasa taas na cleaved part? Is it ketone, carboxylic acid, or a carbon dioxide? I-cleave mo lang ha yung double bond, then you check those cleaved double bond carbon. It will become, okay, very good. This part will become carbon dioxide. So, isang product na dyan, major product, sulat nyo, carbon dioxide. What is the other product kapag ito yung na-cleave? So, yung nasa baba, tingnan mo yung carbon na to. Okay, check mo yung carbon na to ha, yung cleaved portion. This is the cleaved carbon, di ba? Then check the direct attachment niya. This is another carbon, another carbon. So what would be the, sulat ko yung cleave, sulat ko. So this is the cleaved part, yung nasa baba. Ayan. What will happen to this part? Will it become a carbon dioxide, carboxylic acid, or a ketone? Okay, very good. A ketone kasi dalawang R group na yung directly attached to that cleaved carbon. So kapag ketone, yung mismong cleaved part, o tingnan ha, itong cleaved part, diba, ito yung carbon. You simply add here oxygen. That will be the oxidized. Yan yung part na ma-oxidized. So this is already ketone. Diba? Ketone is R, C double bond O, then an R. O, diba? That is a ketone. Okay, so yan yung way to identify the oxidative cleavage products. No, the products. You really have to check the nature of the cleaved parts. Alright? Sige. So, yung ano dito, sa reactions, you really have to try solving. Hindi lang pwede, you just have to read it. You really have to try, practice the identification of the major products, predicting the products, naming the products. You try it all, no? Para mas masanay kayo, no? Sige. We're done, no? We're done with the reactions of alkenes. Okay, reactions ng alkenes. Okay, let me continue. Until alkynes kasi, dapat kasama yung benzene eh. Sige. Dalawa lang yung reaction sa alkynes. Class, and paulit-ulit lang kung ano yung characteristic ng alkenes, the same lang din yung characteristic niya with alkynes. Kasi, di ba, parehas sila mayroong multiple bonds. So, this time, triple bonds na yung present sa alkynes. So, yung alkynes, they also undergo electrophilic addition. Class, please take note. The same with alkenes, they also undergo electrophilic addition reaction. Okay? Electrophile will be added to this reactive site of alkyne. Bakit electrophile will be added? Kasi ito mismo electron-rich na to. So it will act as electron-rich site. So this will act as a nucleophile, no, during polar reaction. So if siya nucleophile na siya, hanap niya would be an electrophile. So, just like alkenes, alkynes will also undergo electrophilic addition. And ano sabi natin kapag addition reaction? Pi bonds will break. No? Yan always yung initially na mangyayari kapag addition reaction. Pi bonds will break. Now, let me ask you, how many pi bonds sa alkynes? How many pi bonds in the functional group ng alkynes? Oh, very good. Dalawa yung pi bonds. Yung isa dyan is a sigma bond. Okay, so you really have to take note nga, okay, dalawang pi bonds yung mabe-break. Okay, so catalytic hydrogenation, this is one of the common reaction ng alkynes. So, catalytic hydrogenation, the electrophile that will be added, hydrogen, in the presence of a catalyst. So, ganun lang din. No? So, you have a hydrogen gas, H2, no? H2, then a catalyst, pwedeng platinum, palladium, nickel. No? These are metal catalysts and they are strong catalysts. I repeat, yung mga metal catalysts, they are strong catalysts. Okay? So, what will initially happen? So, step by step na siya. So, one pi bond will break. One pi bond will break for each of this carbon to be reactive, kaya each will be added with an electrophile H+. Kaya yung makikita nyo, from alkyne, initially, ang intermediate product is alkene. No? Kasi one pi bond pa man ang na-break. Nakuha? So alkene, intermediate product pa yan. The reaction will proceed. Why? Because yung ginamit na catalyst is a strong catalyst. So from alkene, remember na
na-mention natin kanina, ang alkene, they are also prone to catalytic hydrogenation. That's why from alkene, prone pa yan. It will be further reduced. No? It will be further undergo catalytic hydrogenation. Hindi magsa-stop kay alkene. Okay? So magpo-proceed ang reaction, hydrogenation, and finally, the product would be an alkane. Diba kanina sa alkene na hydrogenation, the final product is alkane. Okay, so ang mangyayari lang from alkene, diba meron pa siyang isang pi bond. So that remaining pi bond will break for this carbons, no, to be highly reactive, para maging reactive sila. So another set of hydrogen will be added, no? Ayan. That's why, ang pinaka-final product ng catalytic hydrogenation ng alkynes is alkane. Class, this is only the case if ang catalyst na ginamit is a strong catalyst. Kaya, final product talaga is alkane. Okay? But if your target, desired reaction is hanggang alkene lang, if ever, yung reaction hanggang alkene lang yung gusto nyong mangyari na final product, then, ayan. You can change the catalyst to a Lindlar's catalyst. So, ang Lindlar's catalyst, this is kumbaga, a weak catalyst. No? Weak catalyst siya to the point nga until alkene lang yung product. No? Until alkene lang yung product ng catalytic hydrogenation ng alkyne. So isang pi bond lang kumbaga yung mabre-break, then you will produce alkene. Okay? So yan lang. The same concept lang talaga ng catalytic hydrogenation yung na-discuss natin kanina. Okay? The same concept lang. Ito lang is since triple bond na, okay, triple bond na. And if you wanted to control the reaction nga until alkene lang yung product, then you really have to change the catalyst. Weak catalyst must be utilized here. Okay, so yan yung tandaan nyo, Lindlar's catalyst. If yan yung ginamit sa catalytic hydrogenation, the final product is only until alkene. Okay? And lastly, ito yung last na reaction ng alkynes, we have hydration. Okay. So for hydration, ayan. Yung kailangan naman na reagent, obviously, you need water, no? Hydrate, no? Hydration. And I have mentioned na ang hydration reaction, this is made facilitated with the presence of an acid, no, a source of a proton. So an acid example would be a sulfuric acid plus mercuric sulfate could also facilitate, no, or enhance the acidity of the environment. Okay, so yan yung kailangan na reagent for hydration of alkynes. So kailangan of course mainly water. And ano yung environment? Dapat acidic yung environment. So you will be needing an acid solution. It could be a combination of a sulfuric acid and a mercuric sulfate. So what happens initially, no, kapag hydration of alkynes? So class, ang mangyayari lang po, so breaking the pi bond, ayan, the pi bond will break. And after that, what will happen is addition will be facilitated. So ang mga electrophile that will be added would be ito. You will be having the OH, ayan. Sorry. Ayan. Di na ma-erase. Okay. Okay. OH, ayan, OH will be added at the same time, the H plus will also be added. Ito yung mga electrophile na madederive mo with hydration. The same concept kanina, ang hydration kanina, ang electrophile na ma-add is the OH and the H plus. Okay? yung hydrogen particularly coming from the water, okay? Plus it is enhanced, no, by the acidic, no, acidic nga solution being added. Okay? Sige. So try natin yung initial, how to identify the initial product ng hydration of alkyne. So break the pi bond. Yan, break the pi bond. So facilitate na ngayon mapa-facilitate na ngayon yung addition of the OH and then the H+. Okay? So class ngayon, since we are talking about hydration, you simply follow Markovnikov's rule. Okay, kung saan ma-add yung hydrogen, saan ma-add yung OH, follow Markovnikov's rule. The H+, it will be added to the carbon with greater number of hydrogen substituents. Ayan. And then the OH, doon naman siya sa carbon na lesser hydrogen. In short, Markovnikov's rule. Okay? Yun lang. Hydration ng alkynes in order to produce the intermediate product, you follow Markovnikov's rule. Okay? Kung saan i-attach yung H, saan i-attach yung OH. Okay? So, no problem with the reactive site. Yung reactive site, doon sa triple bond. Okay? So, break the first pi bond, then add the H, add the OH. Yun lang. Markovnikov's rule ha. Follow Markovnikov's rule. Okay? But this is not yet the final product. Okay? Itong naka-bracket, initially, that is an intermediate pa. Intermediate product kasi it can be further rearranged. No? It can be further rearranged yung mismong attachment ng atom sa enol na structure. This is actually an enol kasi 'di ba? You still have a double bond. Isang pi bond lang kasi yung na-break. So it still contains a double bond. Plus nag-add ka 'di ba ng OH. So there is an alcohol, no? Alcohol na characteristics. That's why enol yung intermediate product. Now, from that enol intermediate product, that can be further rearranged. Yung mismong arrangement ng atoms, pwedeng magkaroon pa ng interconversion. Okay? Forming a much more stable na product. Okay? Actually, it will undergo tautomerization. And somehow I have mentioned this. Na-mention ko to sa ato ang previous nga synchronous discussion on constitutional isomerism, yung type na tautomerization o tautomerism. Okay? Yung observable between a keto-enol. Okay? Keto-enol. So from that enol intermediate product, that can undergo tautomerism or tautomerization reaction. And that is simply rearrangement or the movement of hydrogen. Okay, movement of hydrogen lang yung nangyayari dito. So, what happens here, etong parte ng OH, kung saan mo inad yung OH, it will be deprotonated. Deprotonated. De means removal. Removal of proton. So, from OH, remove that hydrogen, and you will be adding that hydrogen to that carbon kung nasaan mas marami. Markovnikov's rule ulit. Okay? Mapupunta yung hydrogen kung saan yung carbon na may greater number of hydrogen. Okay? Kasi rearrangement man ang mangyayari sa tautomerization. Okay? Kasi it shows isomerism kasi. So, from this double bond, ganito class, from this double bond, ang mangyayari, break ulit yung remaining pi bond, mabe-break yung remaining pi bond, and then facilitated na ngayon yung addition, yung further addition. No? So, upon deprotonation okay, deprotonation of that hydroxyl, okay, that hydrogen will be added to that carbon na merong greater number of hydrogen. That's why mapupunta siya dito. Okay, on this carbon. Kasi probably yung carbon na yan, more hydrogen substituent. And then what will happen to this oxygen kanina, okay, that will be stabilized by adding another bond or one more oxygen. So forming a double bond. From single bond, it will just form a double bond. That is just to stabilize the whole structure. So I repeat ha. I-repeat ko lang. Sige. Erase. Okay, dito natin simulan sa enol. Okay, ayan. Ayan, so from this enol, ayan, enol na intermediate product, for the reaction to proceed, this pi bond will break. Tautomerization na siya. The pi bond will break and simultaneously, okay, this hydroxyl portion will be deprotonated. Protonated. So meaning it will be removed with hydrogen. So mare-remove tong hydrogen na to. Saan ngayon papunta yung hydrogen na yan? Since nagkakaroon lang ng rearrangement ng atom, yung hydrogen na yan, preferably, mapupunta siya dito sa reactive carbon with greater number of hydrogen, Markovnikov's rule. Okay, that's why makikita nyo dito, may nalipat, no? Or na rearrange yung hydrogen, okay? Napunta siya sa mismong reactive carbon with greater number of hydrogen substituents. Okay? So, no problem with this carbon. Stable na yung carbon na to. What about this carbon? Ang carbon na to, for it to be stable, it will just form a multiple bond towards that oxygen. That is to stabilize the whole structure. Nakuha? Ito. Ayan. Okay. Galag. Okay. Ayan. Bakit ayaw sumula? Ayun. Ayan. Ayan, class. It will just form a double bond to that oxygen. Itong other carbon. Okay? So, forming now a ketone. No, if you try to look at if you check the whole structure, this is now a ketone. Okay, so purely there is only an interconversion, no, interconversion of the group of atoms, enol to keto, keto to enol. Okay, let's have a specific example. Specific example tayo, class. From this example, 1 propine. The example is 1 propine. And you will observe na yung reagent being added is a water in the presence of an acid plus mercuric sulfate. So this is purely hydration, no? Hydration of alkyne. So initially, what will happen, the first pi bond or one of the pi bond will break. For this electrophile, H plus and OH, to facilitate their addition, okay, yun, mabe-break yung pi bond. So pi bond will break to facilitate the addition of the electrophiles H plus and OH. Ngayon, saan ma-add yung H plus? Saan naman yung OH? Markovnikov's rule, you compare between this carbon, nasaan yung mas maraming hydrogen substituents. Doon mapupunta yung hydrogen as the electrophile. So initially, the product will be, sulat ko ha, CH3, and then dito yung OH. Nakuha. And then double bond, CH2. Nakuha. Okay. Kasi this carbon on the rightmost part, meron pa siyang isang hydrogen. So meaning to say, dyan ma-attach yung hydrogen following the Markovnikov's rule. And then on the other carbon, obviously doon naman yung OH. Okay, so this is not yet the final product. It will undergo tautomerization. Interconversion lang. No? Sa tautomerization, break the pi bond. Ayan. Sorry. Dito tayo. Break the pi bond. I-break natin. Okay? Ayan. So it will become CH3, then C. Isang bond na lang. Ayan. Okay? So after breaking the pi bond, this OH will be deprotonated. Remove the hydrogen. Okay? So magiging oxygen na lang. Okay? Saan mapupunta yung hydrogen na yan? It will be, you compare, saan dyan na carbon, ayan, saan dyan na carbon ang greater number of hydrogen substituents. So obviously on this carbon, dyan mapupunta yung hydrogen, making that CH3. Okay? And then for this carbon to be stable, itong highlighted with color red, for it to be stable, you simply form a double bond towards oxygen. Okay? That is to stabilize. The purpose to that is to stabilize the whole structure, forming now a ketone. Okay? So that is a ketone. Diba? So i-compare mo, merong they are actually tautomers with each other. Kumbaga, mayroong chemical equilibrium being observed sa dalawang molecule, enol to ketone, ketone to enol. Kasi you will just observe movement of hydrogen atom, diba? And then, merong interconversion lang ng bonding pairs. Kanina, ang double bond sa enol, ayan, okay. Ang double bond sa enol is being observed between carbon to carbon, but sa ketone, the double bond is already observed between carbon to oxygen atom. Okay? So that is all about hydration ng alkynes. So those are the two common reactions that alkynes undergo. We have catalytic hydrogenation and the other one is hydration. Okay? Now, for the remaining, practice problem na lang to ha. I-try nyo sa bahay nyo for the reactions ng alkynes ito. And then, for this remaining 3 slides, remaining 3 slides, I will just provide a video material. It's very short, a very short video material on how to identify aromaticity of a particular cyclic compound. Okay? Kasi parte ito ng semifinals. Okay? And sobrang delay na tayo. And we really have to cover everything para hindi kayo dehado sa inyong second year level. Kasi, yun na nga, I've been mentioning this, diba, sa isap sa nako. Sa introduction pa lang or first day of school, first day sa ato ang second semester, yung organic chemistry kasi, it is a prerequisite to 4 of your major subjects next school year. So, kumbaga, hindi nyo ma-enroll yung ibang subject or you cannot understand yun, the higher level ng chemistry, particular sa microbiology, biochem, medicinal organic chem, pharmacology, if you cannot pass organic chemistry. So, dapat ngayon pa lang yung basic. This is part of the basic chemistry. So, dapat basic chemistry pa lang, master nyo na. Okay? Kasi I repeat, i-emphasize gid ako nga prerequisite si organic chemistry for you to enroll 4 major subjects next school year. So, you really have to pass organic chemistry. Okay? If you really wanted to continue your journey nga regular student mo. Okay? So this is a motivation to everyone. I'm not wala ta kong scare, no? Pero it's a fact, no? Fact siya. If you try to check your prospectus, you can ask prospectus. It is a prerequisite subject to your major or higher courses of pharmacy. Ako i-mention ha, microbiology, organic chemistry is biochemistry rather. Biochemistry, pharmacology, and then medicinal organic chemistry. Okay, so yan kailangan ipasa niyo muna yung org chem bago kayo ma-enroll doon na subject. Okay? So, yun. For this three remaining slides, double time lang ta, I will give a video material. Okay? And this is part of semi-final exam din. Supposedly, kasama dapat to pero hindi na talaga kaya. Sige, I will just continue na lang sa grabe no, finals na tayo after next week. So finals na. So, double time ulit. Sige lang. I am confident naman na you could pass the course if you do your part. And I will also do my part. Do not worry. Okay? So, sige. So, that would be all for this afternoon na ba? For this noon. Asa sugod ang coverage? Asa day ta nag-start gani? Where man ta nag-start? Ako pa i-check ha. For midterms, we started nomenclature of alkenes. Doon magsisimula. Which is supposedly remnants na siya no, sa midterm. Oo. So, dito ta mag-start sa alkenes, cycloalkenes, alkynes, what else? Then the isomerism, then until aromaticity. Until dito. Right after this session, I will provide the video materials. Kani ato ang video material ngayon, hindi ko na siya ma-upload, but I will just i-make public, kumbaga, nako itong mga previous nako nga video material sa YouTube channel para diretso rin ninyo ma-access kasi it is really time consuming in my part no, to upload a video material. Kaya I still have to cut and then i-compress. So siya, and it takes time kay naka-HD manggod tanan ang pagka-compress nako. Okay, so lisod siya. Taas kay siya nga process. So, i-public na lang nako diretso tong mga video material. Okay? Sige. So, ayun lang. Mula alkenes hanggang aromaticity. Ito, 3 slides. Okay? Ayan. And I have provided to you the PDF handout already for this topics. Okay? Sige. Yun lang for this noon. No? So, thank you everyone for joining this session. I know it's a very long, no? It's a very long session, but I hope you somehow learn something this morning. Okay? Practice lang yun class. I-practice lang ninyo ang solving sample problems. I-practice nyo yun lahat yung hindi natin sinagot. Okay? It will help you. Okay? Para ma-master yung concept. Okay? Sige, thank you everyone and I'll see you next week no sa examinations. Okay? And by the way, for those students who have not taken the midterm special exam, you can take it together with the semi-final exam or your choice, you can take it the following week. Okay, the following week. It's not a problem with me. Maghulat ko kanus amo take sa inyong special exam. Okay? Sige. I will not check also your permits during the semi-final exam. It's not a problem with me. Ako alang is you take the exam whenever you are available. Okay? Sige. So thank you everybody for joining. Salamat kayo. God bless. Bye-bye. Sige.
Bye-bye.
Thank you.